Okay, this problem you had sent.
Yes, sir.
Did you solve it? Can you try now? My voice is clear.
Yes, sir.
You know how to proceed?
No, sir.
Electron mass is given, no, mass m. Photon have same energy. What is energy of photon?
MC square.
Photon.
Proton.
Photon. What is given in the question?
H-mu.
What about okay, ratio of de Broglie wavelength, right? What is de Broglie wavelength formula?
H by P. Or
Yeah.
H by NV.
Yeah, P of electron is known, right? What is P of electron? Momentum. P is momentum, right?
Yes, sir.
So what is momentum of an electron? Mass into velocity.
Mass into velocity.
Okay, and momentum for a photon?
M into C.
No. M is 0 for a photon. Mass of a photon is 0. Okay, it's h nu by c. This is also a basic relation. You have to remember. Momentum of a photon is h nu by c.
Yes, sir.
Okay, so
Okay, MC only H mu by C. No, sir.
M is 0 for a photon.
Fine.
Mass is 0 for a photon. Okay. So this is a basic relation that you have to remember. Energy of photon is h2, momentum is h nu by c. Okay, so using that, you can write lambda as hc by e, where e is h into nu. So this is clear for a photon.
Yes, sir.
Similarly for electron. So electron, the energy of the electron is kinetic energy. Okay, it's half mv square. That is equal to e. Okay, so from this I can write v in terms of e. So v is 2e by m square root. Okay, so I will take the ratio of h by mv, v replaced by e by 2e by m square root, and then this ratio to calculate. Solve it now. Are you able to do it?
Yes, sir. Option C.
You check the answer.
C only, sir.
Okay, so write in corner of a paper this relation photon, the momentum is h nu by c. Just write it down. This formula you have to remember. Energy of photon you already know, h nu. So momentum is h nu by c, and mass of photon is 0. That also you just write it down. M of photon is 0. Okay, so that you don't get confused. And the energy of electron in general, if they are not said in modern physics, it's mostly kinetic energy. Okay, so don't think of other energy of electron. Electron means it will have only kinetic energy in this circumstance. So energy of an electron is a kinetic energy. It's half mv square. Okay, that's what I've done. Okay, got the answer, no?
Yes, sir.
And you have to find ratio of electron to photon. Right. This question, this is also not difficult. Photon energy, 5 electron volt, incident on cathode, photoelectric effect for the photoelectric cell. So maximum energy emitted of photoelectrons is 2 electron volts. So this is first set of information. Second set is when photons of 6 electron volts incident, number of electrons will reach anode if no photoelectrons will reach the anode if stopping potential of E relative to C is. So as soon as you read the question, you have to write this thing. Okay, the first condition is H2 is 5, right? Electron volts.
Yes, sir.
And then K max, maximum energy of electron. Again, electron is kinetic energy. Because if you look at the photoelectric equation, it's energy conservation equation. It says H2 equal to 5 naught plus K max. So the assumption is there is no other form of energy. So electron will have only kinetic energy. So what do I said? Maximum energy of electron means the kinetic energy. Okay. So and the second set of information is, or the second condition is, or second case is H2 is 6. Okay. So you have to find the stopping potential for this second case. So from the first set of data, what information can you get?
Work function, sir.
Yeah. So how much is it?
3 electron volt.
Yeah. In the second case, again you have to use the energy conservation equation, or you can straight away say that whatever is K max in the second case, okay, that stopping potential should stop that K max, that most energetic electron, right? So K max in the second case is how much?
One electron volt.
No, write the equation properly. K max should be more, right? In the first case, with 5 electron volts, I mean, again, K max has 2. So with 6 electron volts, the K max should
3
be
electron volt.
3. So the stopping potential should be able to stop this K max. So what is the relation then? Relation between the
K
stop.
max equal to 3 electron.
What is the answer?
But I'm confused with that signs or plus P and minus P.
Yeah, stopping voltage is negative potential. No, stopping voltage is the voltage applied to the collecting. See, this is the thing that's collecting the electrons, right? And stopping voltage is applied to this collecting voltage. So this guy, if you have applied negative voltage, then it will repel the electrons.
They have written like a stopping potential with respect to C, anode potential with respect to C means what? So I don't get it.
C means C is
Related to C.
C
Cathode.
is cathode, which emits electrons. This is anode, right?
Yes, sir.
So this thing should be our higher potential. This thing should be negative voltage. If I assume this is 0, relative to C means assume C is 0. Like in relative velocity of V with respect to A, it's VB minus VA, right?
Yes, sir.
So if VA is 0 means the relative velocity is same as VB. Okay. So relative to C means C is the reference. So C is reference means C is 0 voltage. So when C is 0 voltage, this thing has to be negative. So it should be minus 3. Only then it will repel the electrons.
Okay. Do they ask C related to A means?
It will be opposite. No, that means this is grounded, so this is 0 volts. Okay, then this thing should be plus 3. With relative to A means A is grounded. Okay, that means this is 0 volts. So this guy should be 3 volts. Only in the electric field in this direction, the electron will experience a force towards this cathode and will get attracted towards this cathode. Cathode is plus 3, right? And anode is 0. So it will move towards cathode. Wherever it's positive, it will move, right?
Yes, sir.
Relative to C means cathode is 0 and anode is minus 3. So relatively positive is cathode, it will move towards cathode. Is that clear?
Yes, sir.
Work function will not change from case A to case B because it's the same metal. Okay, it is used as cathode. So work function is same in both the cases. So for the first case, you use the data to get the work function and use it in the second case. Okay, this is what we solved some 5 problems in the previous day. So any questions in this one? You have to revise, otherwise you'll be problem. Okay, so any questions in this one? Are you able to
So
open?
another question also I have sent to you, sir.
No, that is out of syllabus. That is a X-ray mission, which is not part. That is previous 2017 or something. Okay, so X-ray mission is not part of syllabus. Okay, we'll move to today's this thing. We'll continue to solve additional problems of nuclear physics. So J and file, are you able to open? Okay, J and file you're able to open, right? Because when you click right click and say new, you're getting this Windows journal document. Journal document. Can you just check right now?
Yes, sir.
If you right click and say new, it should show journal document.
Yes, sir, it shows me.
Okay, so after this Google this thing, you're able to go to that folder. This folder you're able to go. Your internet is slow. I sent you the link, right?
What, sir?
I sent you the link for this folder. Are you able to open it?
JNT.
Are you able to open it?
Yes, sir, 3 lessons I have downloaded. You can open.
Okay, are you able to download?
Yes, sir.
Okay, then fine.
You wait, sir. Let me check again.
Yeah, let it download. We'll continue with the class. So let's try this problem. Nucleus of mass number 240 breaks into 2 fragments. Mass number 120.
Sir, at first you have sent me that electrostatics file, no, sir, but I can't find it.
By mail. I don't know how I sent. No, see, when you right click, see, you right click, got this journal document. No, just click that one.
Yes, sir.
You get an empty document on your desktop. Okay, just double click that and then click yes. From this, you will get this one.
Yes, sir.
Are you able to scribble on this one using the mouse?
Yes, sir.
Okay, this is how the whiteboard works. You can click by, you can save it by clicking this icon, copy disk. Okay, then it's going to work fine. So I'll put the notes in your folder so that you can use this for a quick revision. And if there is doubts, you can go to the video. Okay, but you have to download from this Google Drive. From here, it will not open. This is Windows Journal. This is Google. Okay. Shall we do this problem now?
Yes, sir. 240 is there into each.
Got it?
Yes, sir.
Okay. There are certain keywords here. It's binding energy per nucleon. Okay. And you have to find total gain in binding energy. So binding energy per nucleon is the number of nucleons. The number of nucleons is same on the reactant side and the product side. Okay. Is it clear?
Yes, sir.
This one. This is asked 21. Asked it. This one. Energy equal. This is trivial question. Very, very trivial.
So 45 into 10 power 13.
45 or 4.5?
4.5.
Yeah. So option
A.
this one. This also asked in 2020. Uranium isotope bombarded with neutron generates KR 36, 89, and 3 neutrons. Okay, and okay, plus something. What is that something? This is also a simple question.
Barium, sir. Option D.
Okay. So what did he equate? Number of mass number, right?
No, sir. I equate atomic number, sir. 92 minus 36. Because neutron has no atom number.
What about mass number? That also should match, right?
It's 236 minus 89 plus 3, that is 92.
Okay. So, yeah, so that's also matching, no?
Yes, sir.
See, when you're in home,
140.
try everything, but in the exam you don't have to. Okay, to save time. Okay.
Yes, sir.
This one, nucleus uranium decays at rest into nuclei of thorium and helium. Okay. So helium nucleus has more kinetic energy. Okay, as soon as you read this, you have to note this one at rest. Initially it's at rest. Uranium is at rest. Helium. Helium has more kinetic energy than thorium nucleus. Helium nucleus has less momentum than thorium. Helium nucleus has more momentum than thorium nucleus. Helium nucleus has less. So basically, you have to have an idea of the kinetic energy and momentum of the products. Okay, so initially it's at rest. Okay, so momentum of helium and thorium should be same magnitude wise. Kinetic energy is p square by 2m. Right. So kinetic energy of helium is. Got the answer?
No, sir, I don't know how to do this.
The first thing is it's at rest, no? The initial thing, the reactant. Okay, so what is the initial momentum of the system?
0.
So the final momentum should be 0. So finally, now these two products, the sum is 0. The sum of the momentum is 0. So individually, the momentum can be in opposite directions. Okay.
So,
Okay. So one of the thing can move towards right, the other one towards left. Magnitude of the momentum will be same after getting on the product side. So this is the condition. Momentum of thorium should be equal to the momentum of helium, and let's call it P. Okay. And kinetic energy is P square by 2m. This relation, you know.
yes, sir.
So this also you should remember to be easier if you remember that. So kinetic energy will go as 1 by m, and helium is lighter, right?
Yes, sir.
So the energy,
Helium and
kinetic energy of helium should be more.
option A.
Option A. Again, kinetic energy is the only energy here. Right. Understood?
Yes, sir.
This one, binding energy per nuclei of lithium and helium are 5.6 and 7.06 respectively. Nuclear reaction. Okay, energy is released. So you have to basically have energy of the reactant. Reactant should be same as the energy of the product. So using that, you get the value of Q.
So, what about that binding energy for nucleon of
Yeah.
hydrogen? So,
Hydrogen, there is only one proton, no? One proton means there is zero binding energy. Binding energy is between two things, not two nucleons.
okay, okay.
Hydrogen, there is
No neutron there.
yeah.
If it was a deuterium, then it would have binding energy.
Yeah, yeah.
Okay. 17.3 mega electron volts minus. There is no minus sign.
Actually, binding energy is negative. Okay, but they don't say it because it's understood. See here, see the Q is initial energy minus final energy, right? Because I'm considering
Yes,
energy as this one. Okay, but here is done final minus initial. 4 times 7.06 is 4 in the helium. Okay, so he has done product minus. So binding energy is, see that binding energy curve is there, no, this one, like this. Okay. And we say this is the most stable part, right?
Yes, sir.
Okay.
Iron.
Yeah, iron. See, usually the product of U versus R, okay, the minimum, the stable point is this one, right? Bottom point.
Yes, sir.
So what actually is product here is minus U, or minus of binding energy. Or actually binding energy is called negative, which is negative over there. So potential is actually, this actually inverted curve, they have plotted like this. Okay. So whenever I say the binding energy, it's actually a minus sign is there. So with
Okay,
this,
then you will get it as question. So E final minus E initial, am I right, sir?
whatever way is convenient for you, what I will remember is this one, and then I'll take this thing as minus 5.6. Sorry,
Yes,
minus, reactant is what? Lithium only, right? Minus 5.6 into 7. This thing 4 into minus 7.06.
8 into
Final is what? Yes, 8. Okay. Whatever is convenient for you, remember. But binding energy is negative, but they don't say it because once you say binding energy, it's understood it's negative. Okay.
Yes, sir.
Revise, and then that I will remember. Okay, certain mass of hydrogen is changed to helium by process of fusion. Okay, mass defect. Energy liberated per is given as this one. Yes. So when helium is converted into, so the mass of the product, if it is less, then some mass is getting lost, right? Sorry, binding energy, mass defect. Okay, so that mass will get converted to energy. And what is the relation between mass and energy when the mass is getting converted?
So your voice is low. What happened?
The mass is getting converted to energy. What is the relation between energy and mass?
MC square.
Yeah. So use that to get the answer.
So this U is related to that reactant side or product side, sir?
No, it's a mass defect. So product minus reactants or reactant minus product. See, this is a mass defect of the reaction, entire reaction, not individual nucleus.
Then what do you mean by that per U? Per U means per nuclear, no?
One atomic unit. U is one atomic unit. AMU, the symbol is U, right? Like centimeter, the symbol,
Okay.
the symbol is M. So one AMU, the symbol is U. Okay, so this much of mass is lost. So that will get converted to energy. This mass lost in the reaction. So this is delta M. Delta M in atomic mass unit. So one AMU, when I convert it to energy, how much energy I will get? one atomic mass unit, when I convert to energy, how much energy I'll get?
I don't know.
He has given the question.
What?
921 mega.
Okay.
Okay. So use that to get this one.
But what do you mean by energy liberated per U?
Mm. Okay, here hydrogen is getting fused to helium, right? So hydrogen is what? 1, 1. And helium is 2, 4. Right? Yeah. So basically 4 hydrogen should combine. So, okay. So this is the total energy of this reaction. Okay. So to get per, okay, the question is not very clear. So this is the total energy of this reaction, right? So for one hydrogen atom, this will be whatever is this thing divided by 4. That's what he has done. Delta mc square is the total energy, and the delta mc square divided by 4, that will give per hydrogen atom or hydrogen nucleus. Okay, that the one hydrogen atom is approximately 1 U, right? 1 atomic mass unit.
Yes,
In this reaction, there are 4 atomic mass units on the left side and 4 atomic mass units on the right side. So this reaction is in which 4 atomic units of hydrogen is getting converted to 4 atomic units.
So that U is proton only, sir. For one proton only U, one atomic is U.
Yeah, but there are 4. No, 4 of them should combine to helium. To generate one helium nucleus, you need 4 hydrogen. Sorry. Helium is 2 protons, right?
Yes, sir. Then it means that the energy per nucleon, I guess, so.
Okay, so this is not just simple 4 into something. Okay, whatever, if you look at the reactant side, there are 4 EMUs, right? Because helium has got mass number 4. Helium mass number is 4, right? There is no confusion in that. Yes or no?
Yes.
So this is the energy for generating 4 EMUs. So energy for while generating 1 EMU is this divided by 4. So okay, the question is not very clear. Okay, so the basic reaction is on the left side there are 4 protons, on the right side it has become 2 protons and 2 neutrons. So it means that 2 protons have been converted to 2 neutrons. Okay, so the reaction involves 4 atomic mass unit on the left side and also the 4 atomic mass unit on the product side.
So they have left that C square value, they didn't put that one.
No, that is already given. No, you cannot do that calculation. That's it. That calculation has been made and the answer has been given as 92 megaelectron. If you take 1 AMU, okay, or 1 and put the mass of that 1 AMU and put that C square, we'll get it in megaelectron volts as 931. So they have done this calculation given MC square for 1 atomic mass unit.
Okay.
Okay, so 1 atomic mass is equal to energy of 931 megaelectron volts. And I have how much atomic mass unit? This one. So that will correspond to this into 931. So that conversion calculation they already done.
Okay.
So you have this also a standard result you can remember. Like electron energy levels of electron is minus 13.6 by n square, right? Electron shells.
Yes,
that 13.6 also got by doing some calculation. So similarly, in this mass getting converted to energy in the nuclear reaction, 1 atomic mass unit corresponds to 931 mega electron. This is also a standard thing you can remember. Even if you don't give in the exam, you can use it because it's not going to change. It's like the velocity of light. Okay, this is also a constant. One atomic mass unit corresponds to 931 megaelectron. So if you want to convert it into joules, you have to multiply by 1 into electron charge into 10 raised to 6. Done.
Yes, sir.
This one, fusion reaction takes place at high temperature because this is a theoretical question.
Temperature increase means kinetic energy will rise.
See, for fusion reaction, you have to bring these two hydrogen atoms together or hydrogen nucleus together. Okay, and trying to bring them together, there will be a repulsion. Okay, so to overcome this repulsion, you have to supply some energy. So B is a correct answer. This is a theoretical question. So I think there is no question of breaking up because this is fusion. You have to combine them. In fission reaction, we have to break it up. Okay, atoms get ionized. This is a nuclear reaction, so it's well within the atom. So it's not at atomic level. So this is also wrong. Molecule, it's not molecular level. It's not molecular level. It's not atomic level. It's not breaking up also. Okay, and this is a correct answer. So this is a challenge for fusion reaction because fusion reaction is still not developed in Earth. It's still a research problem, but fission reaction we can do. Okay, so the challenge for this fusion reaction is you have to bring this hydrogen atom closer and closer, and by overcoming the repulsion. So this is the challenge of fusion. So this is the and this can happen at very high temperature, which is there in which place? This high temperature exists where? It's not possible to generate that high temperature on Earth, but somewhere in the nature it's present naturally. Where is that place?
Sun, sir.
And also, okay.
Yes, sir.
Okay, I'm just getting a phone call. I'll come in 5 minutes.
Okay.
Can you just try this question? Have you done it?
Yes, sir. Yes, sir.
What is the answer?
5.5. Option B.
The mass of
They have given del M value.
yeah. So you have to find the mass defect. Okay, so they are given delta M.
Yes, sir.
So and you know the conversion relation between the mass and energy, right? So 1 AEM corresponds to 931. So from that you can find this delta M corresponds to how much energy. So this is the energy per have they given for all the nucleons. So per nucleon is number of nucleons is 7. So divided by 7. Right. This one nucleus. Okay, E is the mass number, Z is atomic number. Yeah, this is a trivial question.
Option D, sir.
B or D?
D.
No, see, mass defect, no. Mass defect means whenever the thing is being formed as a nucleus, the mass will be less. Okay, so the mass, if it is individual protons and neutrons, the mass is this one. But it's actually forming a nucleus, this is the mass. So this is the mass defect. That mass defect means C square is the binding energy.
Yes, sir.
Okay, binding energy is it's actually magnitude of the energy, binding energy. It's always positive. Okay, so the mass of the individual things will be more. When it forms a nucleus, there will be reduction in mass. That goes as binding energy. So correct option is option B. Clear?
Yes, sir.
Okay. Binding of deuterium is this much, and helium is this much. Two deuteriums are fused to form. Okay, this was a trivial question.
Binding. The total binding energy only there is.
So there is a difference in binding energy on the reactant side and product side. The difference will go out as energy.
And here it is not energy per nuclear.
Binding energy of yeah, he has given the total. He has said binding energy of deuterium. So you actually have to write the reaction and balance it, because sometimes it will be like here it's actually two deuteriums, right? Directly helium, one helium. So you have to balance this reaction, and then you have to find the difference in the binding energy.
$23.6.
Plus or minus?
Minus.
No. See, in terms of energy, it's a minus of binding energy.
Oh, God.
And also it's energy release. No, there is a release in energy in this reaction. So the energy release should be positive. If you get
Okay.
negative answer, then its energy is absorbed.
Yes, sir.
So this is basically fusion reaction. So both in fusion reaction, the plot is like this. So fusion reactions, you are moving from here to here. Then also there is release of energy. Fission reaction is moving from here to here. Then also there is release of energy. Okay, and this is iron. Okay, so if it is deuterium is getting out helium, means we are moving in this direction only. Okay, so there will be release of energy. So the energy release should be positive. If it is negative, means energy is absorbed. That's not the case because it's a fusion reaction. Done.
Yes, sir.
This one, in any fission process, the ratio of mass of fission products by mass of parent nucleus. This is also a theoretical question. There is loss of mass or gain of mass. Energy is released, no? It's a fission process. So when energy is released means mass
Loss
is...
and mass.
So mass is lost means product mass should be less, right?
So in both fusion and fission, there is loss of energy.
Yes, loss of mass.
In both fusion and fission.
Yes. That's what I'm saying. When proton and neutron combine, okay, their mass, the total mass is not the mass of individual mass. It's some mass is lost, but the way in which the mass is lost, it depends on the nucleus. So either I come from here or from here towards this thing. Both these circumstances, there is loss of mass. Okay, that mass is coming out of energy. Okay.
Less than 1.
Yeah, option A. Done.
This one.
This one. Fission of nuclei is possible because binding energy per nucleon in them is fission of nuclei increases, decreases with mass drop.
No, option C.
See, this is the plot, right?
Yes, sir.
He's talking about fission.
Up to that peak is a low mass numbers only, sir. Up to high.
So fission means we are going this direction. So there is increase in binding energy with decrease in mass number. So and also this region corresponds to decrease in mass number at higher. Okay, binding energy per nucleon decreases with mass number. Yeah. Binding energy decreases with mass number at high mass numbers. So basically this range, this is the range in which fission happens. Okay, so in this range, as mass number increases, binding energy goes down. You said what? Option A.
C.
Increases with mass number at low mass number. Okay, but here this is fusion. No, at low mass numbers, this is not fission. This is fusion.
Yes, sir.
Okay, and he's talking about fission.
Okay. But fission will happen at high mass numbers only.
No, fission means you have to go from here to here. Okay.
No, they will happen always at high mass numbers only.
No, fission means we have to take this as a reactant. Okay, and my product will be here. Only that process will give me fission energy.
Yes, sir. That the fission happens always in high mass numbers only, sir. Helium will not go fission reaction.
No.
That's what I'm saying.
If you have to make helium into hydrogen, then you have to supply energy. You're going in this direction. Okay, for that you have to supply energy.
Okay, yes, sir.
But here we are trying to extract energy, right?
Yes, sir.
Okay, for radioactive material, half-life is 10 minutes. If initially there are 600, at time taken in minutes for the nucleate. This is also a trivial question, mathematical question.
$20 minutes, sir.
Yeah. So this is what we did, right? Anybody not use minus lambda t, and lambda is given.
No, sir. I use it at shortcut method. N equal to n naught by 2 power n.
Yeah, same thing.
Yes, sir.
And one half-life will go down half by half, so it will be 300. So disintegration of 450 nuclei means the remaining should be 150. Okay. So after 20 minutes, the number of remaining nuclei is 150. Those 450 have disintegrated. Got it? Initially there are 600 nuclei. Okay. So after that time, 450 have disintegrated. So the remaining is 150. So here I have to put 150 equal to 600 into e raised by minus lambda. And lambda is 0.693 by this one. Done?
Yes, sir.
Radioactive material E has decay constant lambda. Okay. Try this one. What is decay constant?
Lambda value, sir.
Yeah. So n equal to n naught. E is for the first one. Let me call it lambda 1 t. Let this be n1. So lambda 1 is 8 lambda. Similarly n2. Okay. And initially they have same. So n naught is same for both E and B. I can also call this E and this thing as E. So NB is the same n naught. E is 1 as lambda. So what is the answer?
1/7 lambda.
Yeah,
I'm getting as minus 1/7 lambda, sir.
lambda is positive quantity. Time should also be positive. Lambda is decay constant, right? It's positive quantity. Time is also positive.
B to that of A only 1/E, no, sir. But here they have done like A to B.
So what is the ratio? So it's
B to that A. So NB by NA.
what time the ratio of the nuclear? See, this thing A is decaying faster, no?
So they have given question wrong also.
Yeah.
They make question.
A to B.
Okay.
Question is wrong. But the answer, but this method is correct.
Okay.
Decay constant of A is more, so A will decay faster. Okay, so A to B, so something is less than 1 means should be A to B.
So
Done?
this one.
Half-life of reactor substance 30 minutes. The time it will take between 40% decay to 85% decay of the same reactor substances. Try this one.
60 minutes, sir.
Yeah. So again, use shortcut.
Yes, sir.
Okay, so this is the basic idea. Half life is this much, 30 minutes. So N1 at time T1, 40% has decayed, right? So remaining will be 0.6.
Yes, sir.
In the second time T2, 85% has decayed, so the remaining will be 0.15. Okay,
Yes, sir.
I have to find T1 minus T2. So if we divide these two, I'll get e raised to the power minus lambda T1 minus T2. So this will be 0.6 by 0.15, which is 4. Okay, so to get rid of this e, I have to take log on both the sides. So it will become ln 4, which is same as 2 ln 2, because 4 is 2 square. Okay, and lambda is 0.693, that is ln 2 by t half. So that is ln 2 by t half. So ln 2 will cancel on both the sides. So t half is given. So from this I can find the time difference. 2 times the t half, so 60 minutes. Okay. Done? Is it done? Okay. This one, radius of this is also a trivial question. You want to do it? Question 10. Your mic is working? Oh.
1 minute, sir.
This is also a trivial question.
The radius of the center is taken to be REL given So previous question 1 minute.
Why so much time? This is the basic.
Cube root of 125.
It's 125 by 27, no? Cube root. R equal to R0 into A raised to power 1 by 3. So first one is R1, E1. Second case R2, E2. If we divide these two, R0 will go away. So the ratio is 125 by 27 raised to the power 1 by 3. 125 raised to the power 1 by 3 is 5, no? 5 cube is 125. 3 cube is 27. So it should be 5 by 3. Option B. Clear? What is the confusion?
Yes, sir, clear.
So if mass number is more means the radius will be more. Okay. And the relation is 1/3. So it's 125 by 127 raised to the power 1/3. The radius of T should be more than radius of element. The factor is 125 by 1 by 27 raised to the power 1/3. Done, no?
Yes, sir. Yes, sir.
Radius to X with half-life this much. Y is stable. Sample of rock from the cave is found to contain X to Y in the ratio 1:7. And the age of rock is
So y part is decayed part or remaining part?
no, X is getting converted to Y.
Okay, okay. So remaining part. So learn 7 values, sir.
Is that actually required?
So ln 7 value is 1.93.
Okay, is it the only way to do it? Just a minute. Option B. Okay, I think I'm not. Okay, x is getting x to y is 1:7, so mass of x by mass of y. It's mass, is it? Okay. Okay, initial total mass p m. So mx plus. Oh, initially itself y is there, is it? Okay, and oh, okay. Okay. So y by 7 equal to m. So 8. So m y is 1/8 part remains. Okay, 3 half lives. Okay, I understood the question wrongly. So initially x and y are there. Initially both x and y are there. Okay, and this thing is getting decayed, and the okay. Okay, it's the mass ratio. Okay, initially both x and y are there, but after some time, the mass ratio has become 1:7 at particular time t. Okay, so the total mass is constant initially. Okay, at the given stage also. So mx plus my equal to the constant mass m. So my is 7/8 of m. So the y that is remaining is 1/8 remains. So 1/8 remains means there are 3 half lives of one. Okay, so 3 half lives means 3 into
7/8 m must have undergone decay.
no, so this is the mass that's currently remaining. At time t, mass of y is 7/8. No. Sorry, my is the converted thing. No, my is the stable part. So mx is okay. My is this much. So mx is 1/8, right?
Yes,
Okay. So mx is 1/8 means 1/8 remains. Okay. So that means after 1 half life, half will remain. After 2 half lives, 1/4 will remain. After 3 half lives, 1/8 will remain. So 3 half lives have gone. Okay. So 3 into half life 1.4. So option C. Let's say initial mass be m, and at time t, mx by my is 1/7. So using these two relations, I can find mx and my. So my at the time t is 7/8. So mx is 1/8. So mx has reduced from, has become 1/8. Okay, he has given an alternate method. So x to y, n by n naught is half is equal to n. Okay, n naught is 1 plus 7. This is more short. Okay, here mx is 1 by 8. So he's assuming that the initial mx is m. Okay, fine. So initially the whole thing is x. Okay, so after the time goes on, x decreases and m increases. So initially mx is m, and at this time, mx is 1 by 8 of m. So mx has gone down from m to 1/8 of m. Okay, so this method is more clear. I think he is using a shortcut here.
This shortcut method, I can't understand. So what they have written? N by.
So forget it. So this is clear, no?
Yes, sir. How did they take n as 3, sir? What have they done?
No, the n by n naught. Okay, forget this one. This is clear for me. See, initially everything is x. Okay, so as time progresses, x decreases and y increases. So let the initial mass be m. Okay, so at any time, mx plus my will be m, and at that particular time t, mx is 1/7 of my. Okay, at the particular time t, the ratio of mass is 1:7. So mx is 1/7 of m. From this we get my at that particular time is this one. So mx at that particular time is 1/8 of m. So initially it was m, just totally x. Now it has become 1/8 of the initial one. So 3 half-lives have gone. So this method is clear for me. This one half-life for radioactive isotope decrease to another element x is stable. What we did, no? Okay. Exactly same. Okay, here the problem is same, but the answer we have to find is different. Half-life is 20 years. The age of the rock is estimated to be. Half-life is 20. Okay, the current age. So how much time has gone? We have to find out that. So how many half-lives have gone? 3 half-lives. So 3 into 20. So the current age is 30, 60. This question number 12 is exactly same, but in different words. Is this clear? Question 12 is okay. Your mic is not working. Your internet is not stable.
Yes, sir.
Okay, so question number 12 is the same as the previous one. So can you figure out?
So here they say decays to another element y, no, sir.
Yeah, previous one is the same thing. X is decaying to y. So at time t equal to 0, the starting point, it's fully x. But as time goes on, x will decrease and y will keep on increasing. So at particular stage, the ratio is 1:7. So from that, we can find number of half-lives that has gone is 3 half-lives have gone because x has reduced to 1/8 of original. Okay, so 3 half-lives. So half-life here is 20. So 3 half-lives means 60. So the age is 60. So option is B. See, initially.
Sir, but if I do in that alternative method means I'll get a y by x equal to 1 by 2 power n.
Forget
So
about
y by x ratio they have given like a what 7:1 y by x ratio.
forget the shortcut. This is straightforward, no?
No, but this method only usually I do to solve problems. This
The problem with
it
shortcut
takes less time.
Is no. This also will take less time because you just have to. There's no tedious calculation. Just multiple steps. When you write it down, it's like this. But if you do it mentally, it will be faster. Because when you're using shortcuts, you have to be 100% sure.
No, sir, this method only it is new for me, but alternative only it's a standard method I follow to for every sums.
Okay, then you figure out both should turn out to be same. But this is a basic idea. Initially, it's fully x. Okay, as time progresses, both x and y will come. So at a particular time t, so this mass of y is 7 times. The ratio is 1:7. Okay, so mass of x will be 1/7 of y. So from this at a particular time, you can find my and mx. So mx at this particular time is 1/8 of the original mass. So m to 1/8 of m, the number of half-life is 3 because 1/8 is 1 by 2 cube. So 3 half-lives are gone. So from that you can find the time. Same thing for this question also. What he's saying the ratio is 1:7. So from that you can find the number of half-lives that have gone. Okay. See, this is total mass, no? So mass of x is 1 and mass of y is 7 times. So total mass is 1 plus 7.
But why they have taken n as 1? That's my question, sir.
What they have taken?
N as 1, no, they have taken.
Which n?
Here that n by n not equal to 1 by 1 plus 7. They have taken n as 1, no.
No. It's n by n naught. Okay, it's a fraction, no?
Yes, sir. N value they didn't mention about it, no. Remaining.
Actually, this 1 is 1 times
X and 7 times Y.
Okay, leave it. Right, it's almost time. So in this Allen module, this nuclei chapter is there, no? Sorry, in
Yes, sir.
Akash module.
Yes, sir.
So in that exercises, how many problems you can solve now?
No, I have solved only previous year questions and not exercise problems.
So after that is over, move on to the exercise questions. And exercise questions don't, it will be from simple to hard, no? So try from medium and hard questions, few of them. Pick at random and try, and then see if
Yes, sir.
you will solve it. Okay, and so this
Yes, sir.
J file you're able to open, no?
Yes, sir.
So I'll put this class notes after. I'll do some cleaning and put it there. So you open this for quick revision. Okay, and
Yes,
after
sir.
also watch the video if you have some doubts. Yeah, so it will be in your folder here. So this JND file, I'll create folder for different chapters. I put PH11, right? So I put
Yes, sir.
download and then see it, check it. Right. So tomorrow is Sunday. You want to
Yes,
have class?
Yes, sir. We have to complete the portion, no, sir.
Yeah. So the thing is, on 9th I'm going to Chennai. Okay.
Okay.
9th I'll be traveling. So 10th we can have class. 11, 12. But I might have some work while I'm in Chennai. So the timing I might shift it to 7:30 if I'm doing some other work.
Yes, sir.
So and the internet connection there might be a little bit slow. So we have to adjust.
Okay, fine, sir.
Okay. So you have an approximate plan of when the thing is going to get over. Your exams in July, no?
Yes, sir.
So is the thing according to your plan? You should have planned something, right? In the sense, within this much time, I have to finish this much. So this is the
In
block.
physics, I didn't plan, sir. The complete work.
Okay. So modern physics right now, I think it's almost over. Modern
Yes, sir.
real nature of light, and then atomic physics, nuclear physics. Okay. Kinematics also we have done. Electrostatics we have done. Capacitance, Newton laws of motion. Current electricity we have done. Work energy power, yes. I think it's almost done. Circular motion we have done. So this is thermal physics, units and dimension, magnetic fields, and physics of materials. So this thing we have to do. Last 4.
Unit and dimension we have done now, sir.
Yeah, this is trivial only. So basically
Yes,
we have to do thermal physics, and then thermal physics also he has put KTG and thermo as separate. Okay, so here might be just expansion of solids, because KTG is put separately, and thermodynamics, most probably this is thermodynamics. Okay, so this is magnetic fields, and this is physics of material or physics of matter, surface tension, like that, those things. Okay, so biology and chemistry, how much portion you have complete? How are you planning? So biology and chemistry, you have finished the full portion.
No, sir.
Why not?
No, I complete only 30%.
This you're repeating, no? So all the portions of syllabus were completed long time back itself. You just have to revise now. So
Yes, sir, but
and
I'm
when are you going to give
sleeping.
full mock test?
April, sir. April.
Okay, right now you have to give some part test. There must be a lot of tests in the Alan module, Akash module, right?
Yes, sir. Chapter wise test.
Yeah, try those tests with the time limits, and then you have to fix this biological clock. You should. What time you sleep in the night?
10 to 5, sir.
10 to 5. So that's okay. So morning slot you have some 3 hours. I mean, sit at one place in 3 hours and study continuously. An afternoon session or evening session, sit for another 3 hours. You should get in the habit of sitting in one place for 3 hours. Okay, you have to be mentally tough. Otherwise, studying and then the mind has to work properly during the exam. So the exam situation you have to stimulate at home. So while studying itself, you should get in the habit of sitting at one place and studying for 3 hours. So just try if you cannot just make it 2 hours, if you cannot just make it 1 hour, and then slowly increase it 1.5 hours, 2 hours, 3 hours. Okay.
Yes, sir.
Okay. So tomorrow will be tomorrow.
Yes, sir. I'm planning to join any offline test series, sir.
Yeah. So which one?
Akash or Venper, or else I don't know if Kerala NEET Academy provide this or not.
How much do they charge?
I don't know, sir. I have to inquire about it.
Okay, definitely you have to take mock test.
Offline, sir, because last time online and I couldn't do well in exam.
Okay.
I couldn't manage time. I messed up the one.
No. The first thing is you have to sit at one place and study for 3 hours continuously. Even while studying,
Yes.
just sit at one place.
Yes,
Unless it's absolutely necessary, you have to get up. Otherwise, you just have to sit at one place.
yes, sir.
So if you cannot sit for 3 hours, sit for 2 hours, and then slowly increase it. Or if you can sit for 1 hour, make it 1.5, 2, and then 2.5, 3. Okay, but ultimately you have to attain the 3 hours limit. Okay.
Yes, sir. And I have to improve my time management also.
No, that is fine. That is one thing. After that, can you sit at one place for 3 hours?
Yes, sir.
Okay, then you have to increase the speed. Increase in speed will come if the concepts are clear. Okay, another thing is practice. Two things.
Yes, sure.
So right now